Hello, my name is Priya Wilku, and today I'll be presenting my project on signal noise analysis and reduction in MATLAB. This project focuses on understanding, creating, and reducing noise in audio signals using various techniques. I will walk you through the methodology I used, the effectiveness of different noise reduction filters, and the challenges I faced. I began this project by loading the audio file, specifically the ice cream audio file, using the audio read function in MATLAB. I played the audio using the sound function, which allowed me to listen to the original audio and understand its quality. To get a better understanding of the signal, I plotted the audio signal over time, which helped me spot any fluctuations, spikes, or drops in amplitude. This is an important first step in signal processing because it helps identify any irregularities. After visualizing the audio in the time domain, I moved to frequency analysis using the fast Fourier transformation, or FFT function. The FFT function helps identify the frequency components of the signal. A clean signal will have a smooth frequency pattern, but any unwanted noise will appear as additional peaks or fluctuations in the spectrum. This step was essential to understand what type of noise was present. To test my noise reduction techniques, I first needed to create noisy versions of the audio. I added two types of noise: Gaussian noise, which is a random normal distribution, and a uniform noise, which is a constant amplitude range. This stimulated a real-world noisy environment, making the analysis and filtering process more realistic. I then applied various filters to reduce the noise in the audio. I started with a low-pass filter, which allowed low-frequency components to pass through while blocking high-frequency noise. I also tested band-pass filters, which focus on specific range of frequencies, making them effective for signals with known frequency ranges. Finally, I use a Werner filter, which is adaptive and adjusts based on the signal's characteristics. I tested these filters to see which one performed the best. Just to quickly explain the different filters I used, the low-pass filters allow low frequencies to pass, removing high-frequency noise. The band-pass filter focuses on specific range of frequencies. The Werner filter is an adaptive filter that minimizes the average error between the noisy and clean signal. I also tested a medium filter, which replaces each value with the median of its neighbors, making it useful for removing impulse noise. I faced several challenges during this project. The first issue was loading the audio file. I tried multiple methods, but most did not work properly. I eventually found that the audio read function was the most reliable. I also considered using a try/catch block for error handling, but the structure of my code didn't work well with it. Another challenge was finding the right filter. Low-pass filters removed high-frequency noise but made the audio sound muffled. I tested several filters, including low-pass, high-pass, and band-pass filters. After extensive testing, I determined that the Werner filter was the best because it adjusts dynamically to the signal's characteristics, providing the highest signal-to-noise ratio and the lowest mean squared error. In this project, I successfully explored the process of analyzing, creating, and reducing noise in audio signals using MATLAB. By working with the ice cream audio file, I gained hands-on experience with various signal processing techniques. This project taught me the importance of balancing noise reduction with signal preservation. I also learned that different filters work best for different noise types, and that an adaptive approach like the Werner filter can provide superior results. Overall, this experience enhanced my understanding of signal processing and noise reduction, skills that are essential in many real-world applications. Thank you, and have a good day.